I am very honored to give this speech at ICGCS 2021. My name is Pengtao, and I am a postgraduate student from National University of Defense Technology, China, which is also the organization of our co-authors in this paper. Today, I want to talk about some of our work in the field of big data. As you can see, the title of our paper is The Vertical Cuckoo Filters, a family of insertion-friendly sketches for online applications. I will give this talk in 4 parts. The first part deals with the introduction of probabilistic data structures. The second part concerns our sketch design, which is a vertical Cuckoo filter. The third part related to evaluation of our design, and then the last part is our conclusions. Nowadays, many caches, routers, and storage systems in networking and distributed systems relying on space-efficient data structures to decide whether a given item exists in a large set of items. To that end, probabilistic data structures become an important machinery, such as Bloom filter and Cuckoo filter. Cuckoo filter is proposed for better space utilization and faster deletion. As the picture shows, a Cuckoo filter is a table of M buckets, each of which contains B slots, and it stores the item fingerprints directly in 2 candidate buckets. To insert the fingerprint of X, Cuckoo filter provides 2 candidate buckets, which is bucket 1 and bucket 2, through the partial Cuckoo hashing technique. Thereafter, the fingerprint of X is stored in bucket 1 or bucket 2 if there is an empty slot. If both candidates are occupied, the Cuckoo filter performs the eviction. It randomly kicks out a fingerprint in one of the candidates, such as A in this picture, and then reinserts the fingerprint of X in the slot that has just been vacated. At the same time, Cuckoo filter calculates the other candidate bucket of the victim fingerprint and tries to reinsert it into that bucket. The eviction process mentioned above is like a turtle dove takes over the nest of a magpie. This is also the origin of the name of Cuckoo filter. The Cuckoo filter relies on the reallocation process, while it only provides 2 candidate buckets, which causes no space utilization and insertion time consuming, especially when the filter is nearly full. As a result, we need an elegant approach to increase the number of candidate buckets, while preserving the simplicity of sketching operations. So we come up with vertical hashing that can divide the fingerprint hash value into multiple fragments by using bit masks, thereby providing more candidate buckets. As shown in the figure, we use an 8-bit fingerprint as an example, and the fingerprint hash value of the inserted item is 1003100. Thereafter, vertical hashing performs AND operations between the F and the first bit mask, BM1, so it is derived that the hash value fragments F1 is equal to 1001140. In the same way, F2 is equal to 4011 and 00. Then, based on the 2 fragments of fingerprint hash value, we can get 4 candidate buckets. It's easy to prove that as long as the 2-bit masks are inverse to each other, vertical hashing can circularly access all 4 candidate buckets for any item through its current location, fingerprint, and bit masks, without additional hash computation nor the access of its content. This figure shows the structure of VCF as well as an illustrative example of VCF insertion. So VCF improves the load factor by providing more candidate buckets. It also causes an increase in false positives. So we further design 2 variants of VCF to realize a proper trade-off between false positive rate and load factor, called IVCF and DVCF. IVCF realizes dynamic adjustments of performance by changing the bit masks in VCF, while DVCF sets an adjustable threshold and differentiates fingerprints to achieve almost the same effect as IVCF. Please see the paper for more details. To better illustrate the advancements of vertical hashing, we conducted comprehensive experiments on Cuckoo filter, vertical Cuckoo filter, and its variants. Besides, we also conducted experiments on Deke Cuckoo filter. It also called DCF in the figure, which is also a variant of Cuckoo filter, and it can increase the number of candidate buckets in a more complicated way. Through the experimental results, we can see that the more candidate buckets VCF provides, the higher the space utilization and the net time cost of insertion. As you can see in those figures, the more candidate buckets VCF provides, the worse the performance of lookup and false positives. The contributions of this paper can be summarized as follows. First, we present the vertical hashing strategy and use it to design VCF. Second, we further design IVCF and DVCF to make performance matrix tunable. Third, we conduct theoretic analysis and comprehensive experiments to compare VCF with the existing methods. The numeric results demonstrate that half of the insertion time overhead, an increment of space utilization, and an acceptable compromise of lookup speed. That's all for my presentation. Thank you for your listening.